This is the Mathematics Education Podcast from mathedpodcast.com. Welcome to the Math Ed Podcast. My name is Sam Otten from the University of Missouri, and my guest today is Amanda Jansen, who's an associate professor in the School of Education at the University of Delaware. Amanda, thanks for being here.
Thanks for having me.
We're going to be discussing Amanda's new article with Beth Herbal-Eisenman and Jack Smith that's entitled Detecting Students' Experiences of Discontinuities Between Middle School and High School Mathematics Programs, Learning During Boundary Crossing. And that article is appearing in the current issue of Mathematical Thinking and Learning. But before we get to that article, I actually wanted to back up and ask Amanda to tell us a little bit about her dissertation and her graduate studies.
Thanks, Sam. So I graduated from Michigan State University in 2004. So my dissertation was some time ago, but I still really care about and I'm interested in the ideas. So that's fun that you asked me to talk about it. I studied middle school students' participation in classroom discourse. I wanted to really capture variation in how students participated. I wanted to make sense, basically, out of why middle school students get involved in class discussions in different ways. Some people get really involved, some don't, and what's going on there. I think I was really responding to, at the time, the principles and standards of school mathematics were the standards that people were talking about. And they have process standards by grade band, and one is communication. And if you look at the one for middle grades, it says, basically, that for middle grade students, they might be hesitant to participate because they might be afraid of being wrong. And I was thinking that might be true, but there might be a lot more to understand.
Yeah, it seems a little simple to just say, fear of being wrong. It seems like there'd be a lot of factors in students' motivation to engage. That's
right. And I understand it's a big document and there's only so much they can say, but I wanted to kind of get underneath that more and understand, okay, how prevalent is that point of view, for instance, and what are other reasons why students do or do not get engaged, and why do they, not just why don't they, right? So, so for this study, I was in 2 classrooms, and I wanted to see if there were similar reasons why students did or didn't participate with 2 different classrooms, because there was different opportunities to participate in each classroom. The teachers implemented the curriculum differently, for instance. So I interviewed kids, and I observed them, and I found some similarities across the 2 classrooms, even though they were different. So also at the time, in the theory side of math ed research, a lot of discussion about student engagement of classroom discourse is really at the collective level, the group level, normative classroom practices, and so I thought it would be a great contribution then to unpack variation. So I was trying to respond to that issue with theory.
And in your dissertation study, you were interviewing students and were trying to really get at the students' voice in terms of their own participation in the mathematics classrooms. Is that true?
That's right. So I spent a lot of time talking to students one-on-one about their experience in classrooms. Middle school students, I was a former middle school teacher, and I really wanted to make sense out of how they were interpreting their opportunities to get involved and what it was like for them. And I went into the study thinking they were going to say certain things, and it was totally different. And I thought they were going to talk about, because I'm trying to make connections between people's ideas, because math is a really connected body of knowledge. That's not how a 7th grader talks. So kids ended up talking about social issues in ways that I didn't anticipate, just because I hadn't been thinking about it from their perspective as much. So I learned about their point of view a lot. And I learned, so to go back to the communication process standard, I learned that the students who were afraid of being wrong, they still participated, but they participated in certain times. So they seemed to avoid the more challenging ideas to talk about, like conceptual conversations, but they did participate when it was more procedural conversations, like what's the next step. And I think for them that was a little bit less threatening of a conversation. So it wasn't as if they were avoiding participation entirely, but they were avoiding high-risk participation. So that complexified that process standard for me.
Yeah, that sounds like really interesting work, and I know you've, since the dissertation, you've published that in journals that people can go and find, and I'll, on the website for the podcast episode, I'll actually put some links to those articles if people are interested in this work from your dissertation. And then the article appearing currently in Mathematical Thinking and Learning, it sounds like you're also really investigating students' experiences, and it still does relate to that middle school level, but now you're looking at the transition to the high school level. So I was wondering if you could tell us about your personal motivations for continuing this work and now leading to the present study.
Yeah, thanks. So a range of the work I've conducted really does foreground student voice. Interview data with young people ends up being the leading data source in a lot of these pieces. So when I was a middle school teacher, one of the reasons why I wanted to get into research was I was very curious about students' experiences in my classroom and were they making sense out of the experience in ways that I intended or that I couldn't have predicted. And so I was very passionate about the idea of spending more time getting to know students. And I did that as a teacher, but I thought as a researcher I was able to do that in a way that was much more nuanced and detailed, and so it really does drive a lot of what I do is trying to understand the classroom from the student's point of view. And I think that students' perspectives is sort of a black box to understand relationships between teaching and learning and curriculum, really getting a sense of how students mediate all of those processes that ultimately leads to their understanding is pretty important. In terms of the transition to high school, I actually worked at a school that was 7, 8, and 9 in one school. So I taught both middle school content and high school content. And so they were making the transition in content in one building, and then they didn't make a transition to a high school building until after they were already taking classes for high school credit. So I was interested in more of the typical structure, but I guess there's so many different configurations too.
And regardless of the configuration, there are a lot of transitions that are happening to different buildings, different kinds of responsibilities, different teachers, and then different mathematical content and expectations. So they might be configured differently, but there's a lot that's transitioning from those middle school grade levels to high school.
Exactly. So I was curious about if I was supporting students enough and what would it take to understand how to support students better with transitions, and again, leading with student voice to help me make sense out of that.
In the current article, you took as research questions, you and your co-authors were wondering, how can researchers detect discontinuities from the student's perspective in this transition from middle school to high school, or really discontinuities in other transitions as well? And you also had the question of what was the nature of students learning through those discontinuities? And so the idea of discontinuity is going to be central. I'll ask you a little bit later to really describe what you mean by discontinuity, but first just situate us with the data that you looked at for this study and where that data came from.
Okay, so this article is based on a subset of data from a larger project. Jack Smith was the principal investigator of a project called the Mathematical Transitions Project, and it was funded by NSF. And so the idea behind this project, it was to understand the transition both from middle school into high school and from high school into college. So we had 2 sites of students moving into high school and 2 sites of students moving into college. So we had that building shift. But we also wanted to investigate moving into or out of particular curricular approaches, curriculum materials with different kinds of emphasis. So for lack of a better phrase, I'll just use shorthand. So reform and traditional, even though it's more complicated than that. So we had a middle school where students were moving out of connected mathematics, which is more of an integrated, problem-based set of curriculum materials, into a high school that was more topic-based and emphasized procedural fluency a bit more. And then we had the opposite, so we had students from a middle school that was more of an emphasis on procedural fluency and it was more topics-based, into a high school that used Core Plus, which is more problem-based and integrated. So we had the 2 different directions of curricular shift going on. And then we also had that at college level. We had students going from a more of a procedural high school into Harvard Consortium Calculus. And then we had students going from Core Plus in high school to more of a procedural focus on calculus in college. So we're trying to get both the building shift and the curricular shift. So we had a 2x2. It's hard to show without a diagram. But that was the larger project. And we followed students for about 2.5, 3 years, and about 25 to 30 students at each site. And we collected data such as interviews multiple times a year with our focus students. Students kept journals for us when we weren't there, either written or audio, and we observed their math classrooms. In my case, I was responsible for collecting data at one of those sites, so I was at that high school a lot and observing them, interviewing, going with them to their classes over the years. And so this paper focuses on data from the high school site where I spent a lot of time. So this was where they had connected mathematics in middle school, and they went into this high school that was more procedurally focused and not integrated across topic areas. So it was really important to me to think about a way to write a paper that told a story about this specific site.
Okay. So with that background, I'm going to ask you to tell us a little bit about what you found with respect to your research questions. But the first research question is actually about how researchers can detect student discontinuities or discontinuities from the student perspective. So how was it in this study that you operationalized the idea of discontinuities, and how did you try to take on that student perspective?
So we were trying to think about the project as a whole like this. As researchers, as teachers, as math educators, we thought the students were having a really different experience as they would go from this middle school into that high school. It was a small school district, so there was only one middle school that fed into that one high school, but we still saw the two buildings as very different. But that doesn't mean the differences that we noticed were a big deal to them. So we really wanted to foreground the idea that a discontinuity are differences that the students notice that matter to them, that are bumps in their experience. So a discontinuity for us would be differences between settings that are, for shorthand, that are a big deal to that participant. So it could be different teaching practices, it could be different types of mathematics problems, but whatever the students saw as different and important enough to affect their experience. So not what we thought was a big deal, what they thought was a big deal.
And you talk about in the paper, too, about how the students identify those differences, but then it also had to be accompanied by an attitude change. Is that true?
So in this project, the Mathematical Transitions Project, the idea behind this project is we wanted to come up with identifying a range of types of transitions that students might experience. So we had 4 different components that we thought would be potential changes that students could experience over time. So one of those was change in achievement, and typically in studies about transition into high school, we hear about achievement studies, and statistically, students' achievement drops a little as they move from middle school to high school. So that was one of the factors we looked at, but we also wanted to look at additional issues like whether students' dispositions toward mathematics improved or did not, whether their approach to learning was any different, did they study in different ways, something like that. And so it was learning approach, disposition change, achievement change, and then any differences. So characterizing what differences students noticed. So we said that they had a type of transition where it was any 2 of those 4 differences, achievement, disposition, or learning approach. So any combination of 2 of those 4 changing was a transition type. So this paper, so this paper was meant to highlight one of the transition types. No achievement change, noticing a lot of differences between the programs, and your disposition changing. Because at the 2 high school sites, that was actually the most common transition type. Because there could have been lots of different combinations of changes in those 4 dimensions. And so since this was the most common type of transition that students experience at both high schools, actually no achievement change, so that's different from the literature, but their disposition changed and they noticed a lot of differences, we thought we wanted to push on saying if you only look at achievement, you're going to miss a lot. And when you do try to understand students' perspectives of what they notice is different and how they might respond to that, could be a change in their disposition. This paper is really meant to highlight that transition type. Regarding how we analyze for the discontinuities, we developed a framework, and this was another piece that I had the opportunity to take the lead on in the Mathematical Transitions Project, to propose to the group ways of analyzing the interviews to determine whether or not students notice significant differences. Because imagine like this, you're asking somebody over and over for 2.5 years, what's different between middle school and high school? They're gonna, they're going to tell you lots of things because you ask them. So we needed a way to analyze the data to distinguish between polite answers to our questions and differences that really mattered to them. I proposed to the group different ways of analyzing and doing some sort of discourse analysis of the interviews themselves, and then as a group, we debated different techniques, and as a group, we landed on some analytic techniques to identify discontinuities. And so to find out not only just which differences students notice, but which ones they seem to value, which ones seem to matter to them. So we looked at this idea of repetition in the interview, kind of like if an orator is repeating something on purpose for emphasis. People do this in conversation almost unconsciously. You repeat yourself to kind of emphasize yourself. So we looked at repetition within and across interviews with the idea that it was more important of a difference if it kept coming up. And then we also looked at if students spoke about the difference with strong affect, really strong emotional tone in their voice with emotional terms, and if they used emphasis or hedging terms. So if they said, kind of, sort of, then it probably wasn't as significant for them as if they said, really, definitely, absolutely. So we wanted to use those three techniques, repetition, affect, and emphasis terms, to really distinguish between differences that mattered to them and differences that they just sort of mentioned offhand. So that was more about how we operationalized this idea of seeing the discontinuities in the interviews themselves.
So once you've identified these discontinuities for different students, then you had the question about the nature of students learning through those discontinuities, and you bring in a framework of learning mechanisms, and particularly in the article you use the idea of identification and reflection as learning mechanisms as students move through transition points or through discontinuities. So I was wondering if you could say a little bit about those learning mechanisms, and then we can talk about the two cases that you present in the article.
Yes, I would like to talk about that. So we'd been struggling for actually a while about how to write this article. It was really important to me to tell a finer grain size story about the data from this project, because the other publications from this project had been more about the whole group, the larger group across the 4 sites. And I wanted to tell more of a qualitative, detailed story so the students' experiences would come alive. It was a different take. And really looking at students' sense-making of the experience. And so this idea of learning through boundary crossing came from a literature review. It's an Ackerman and Baker piece that we cite heavily throughout the work. It's a piece in RER. And so they talk about this idea of learning during boundary crossing, and they push on the idea of what counts as learning in these boundary crossing experiences. So when you're moving from one setting to the other, when there's a discontinuity, that's a boundary crossing. And as you're making sense out of what's happening, there's different kinds of learning that can take place. And it may not look like traditional learning, like acquiring mathematics content, procedures, skills, or developing reasoning, but it's a different kind of, anytime you're making sense out of the world, that's learning something. And so this idea of identification, that is, if you're making sense out of the world in terms of who am I, your own identity. So thinking about Bethany is a case, she exemplified this idea of identification. So Ackerman and Baker talk about this idea of identification as reaffirming your identity from the previous setting and employing those practices in the current setting. So it's learning about who you are, learning what your identity is. Bethany really valued her opportunities to do math and reason about math like she had in middle school. And she actually really fought to retain those practices and bring them into high school, even when her high school experiences didn't provide her with clear opportunities to do that. So she really wanted to use her own solution strategies, for example. She wanted to solve problems in a way that made sense to her, and she really wanted a chance to talk about it and use those strategies. And in high school, she wasn't invited to do that, and she was actively discouraged from doing that. Points off on tests for using a strategy that was different from the teachers. She got to 10th grade, and she was a little frustrated because she had been busy trying to make sense out of it herself and do her own strategy on the side of the paper, and she would talk about all the time how she wanted to solve it in her own way because she knew it worked. And she had a big discussion with her 10th grade teacher about a strategy that worked that was also correct, and he almost didn't listen to her, and then he actually did acknowledge that she had a correct strategy. So she really did find ways to retain these practices that she valued from the previous setting into that new setting. So it was all about understanding who she was as a math learner. And so that's why we called that sense-making process identification.
So if I can sort of make sure I'm understanding this correctly, so she experienced the discontinuity between middle school and high school, where in high school there wasn't quite the openness for her to pursue her own solution strategies or share and talk about those. But through that discontinuity, she actually reaffirmed to herself that I am the type of person, the type of math learner that wants to explore my own solution strategies and wants to have those validated?
That's right.
Okay.
Really wanted to do the problems in the way that made sense to her. She still did try to understand her teacher's strategies, but she fought to retain that other opportunity. And so in the Ackerman and Baker piece, they were not looking at literature and math education specifically. They were looking at literature in all kinds of transitions. So one of the contributions of this piece is taking their ideas and seeing what they might look like in transitions in math education settings. So really unpacking what that identification process could look like, how it's relevant to thinking about this transition.
So reflection is another learning mechanism, and you exemplified that one with the case of Ethan in the article. So could you say a little bit about Ethan?
Yes, so Ethan, he's an example of reflection because the idea here is you're constructing this new identity and you're expanding your perspectives and practices by making sense out of the practices in both settings. So it's like you understand both and you are interested in both. So Bethany, her disposition actually got worse as she went into high school. So she was an example of noticed significant differences and disposition sort of dropped. And Ethan was an example of someone who noticed significant differences and his disposition improved. But we called him reflection because he sort of called himself, he actually used the phrase in one of the interviews of, I'm an ambidextrous math student. Because he said he tried to understand what was expected of him in both high school and middle school and just kind of adapted it to each one. I mean, it turned out that he happened to like high school better, but he said it didn't really matter, that he knew what was expected of him in middle school, so he would do that. And then he figured out what was expected of him in high school, so he did that, and he just could adapt accordingly. So he actually broadened his perspectives of beliefs about what it meant to learn math, because he had been exposed to a middle school approach, but then when he went into high school, he got a broader approach and developed a wider range of beliefs about what it meant to learn math and to do math through reflection. And he's also literally very reflective. In his interviews, he used a lot of metaphors. Mm-hmm. So one nice example is water filling an ice cube tray, and he would talk about how in middle school, the water would slowly fill each piece of the ice cube tray, that it would just go slowly through. And in high school, you just rush through over that ice cube tray and stuff it in the freezer. And he said he said that he liked that better because it was more challenging to go over it more quickly. And he would also use different metaphors like stepping stones crossing a creek, and whether they were further spread apart or whether they were carefully nearby each other, stepping stones. So
Where in middle school, the middle school case was the larger stepping stones, but a lot of small stepping stones in between so that you can always take small steps, right?
Exactly. So he would use these different ways of trying to compare and contrast. Here it's like this, there it's like that. And this sense that he had this broader range of what it means to learn and do math in these different cases, that's why he was more in the reflection category.
Great, and I think in the article you do a really nice job of presenting those two cases in detail, and you do kind of bring those students to life. And so I think you did achieve, like you were saying, you were hoping to do with this article, in contrast to some of the other articles from the project, to try to give those qualitative stories or narratives about particular students.
Yeah, it's a tough thing to do, and I think the generalizable point is the two different processes of sense-making. So how to tell really detailed stories where you really feel like what it's like to be these students, but in a way where it just doesn't stay at the level of the story. So the nature of sense-making being different with the different students, I think that is a piece that can be applied to think about other students.
I'm talking with Amanda Jansen from the University of Delaware about her new article, Detecting Students' Experiences of Discontinuities Between Middle School and High School Mathematics Programs, which is appearing in Mathematical Thinking and Learning. And I do want to ask you, Mandy, if you can summarize this takeaway point or a key idea from the article that you want to leave the listeners with.
Sure. In this article, I really liked the opportunity to push on this idea of what counts as learning from school math experience. So the article, we tried to offer different ways to think about how students are making sense out of this transition experience, and we wanted to think about defining learning broadly, making sense about your identities, who you are as learners, and making sense about your beliefs about learning and doing math over time. So like how Bethany fought to maintain her prior practices and her identity in a new setting. And in some ways, I might say that this kind of learning could be more personally meaningful, or at least equally meaningful to students, in contrast to they might forget the quadratic formula, but they might remember how they felt about who they were in math class. So I really wanted to take that opportunity to push on what counts as learning.
And do you have next steps that you or that the project team is taking beyond this study?
So I am collaborating with some colleagues at the University of Delaware to try to think about opportunities to work on the transition to college, and we've been working with the math department and thinking with them about what their mathematics courses look like and how they're similar to and different from our high school program here at the state of Delaware. All the high schools in Delaware use either Core Plus or IMP, and then the mathematics department is getting calls all the time about how the students might be doing in college compared to high school. Another research project I'm involved in, it's a grant from the National Science Foundation with my colleagues at the University of Delaware. It's related to the idea of transitions. We have a grant from the Reese part of the National Science Foundation to follow graduates from our teacher education program. So the way of thinking about transition here, it's university pre-service teachers transitioning out of the pre-service mathematics education courses into their full-time teaching jobs as elementary and middle school teachers. So some of the ways I've been thinking about transitions from the Mathematical Transitions Project, I've been able to think about as frameworks for developing interview protocols for the case study part of this project. So it's a large-scale project following cohorts of students from our pre-service teacher program into the field, into their full-time jobs, and we're getting measures of their math knowledge for teaching and their ability to analyze teaching once they're in the field. That's for the large-scale part of the study through paper and pencil tasks and video analysis tasks online. But I'm working with some case studies from this project and looking at how they are implementing their lessons in the field, how conceptual the lessons are, and also trying to get a sense of how they're processing the transition experience. So that's another study I'm involved in that's related to transitions as well. We'll be presenting about that this year at NCTM at the research pre-session, if people are interested. But I think in general, the larger next step I'm taking is often when we talk about transitions or students' experience, we think about what went wrong and how can we fix it. I like to think about what they were able to do, what went well, and how to build on that. So focusing on building upon strengths that students are bringing into the new settings rather than focusing on trying to ameliorate deficits. So if students are coming into a more traditional setting in high school or college, rather than saying first, oh, they don't know their skills, well, what do they know? And build on that and then get them to the point of being more proficient in skills. So really looking at how to build upon students' strengths.
My guest is Mandy Jansen, and I do want to ask you one more question before I let you go, and it's actually not related to mathematics education. I was wondering, if you were not in mathematics education for your career, what would you see yourself doing?
Sometimes I like to answer this question and laugh and say, oh, I would like to be a pop star like Kelly Clarkson. Because I used to sing a lot, but I know that's not realistic. That's like saying, oh, I want to be a basketball star. But I think that, so the other path that I thought about pursuing seriously was more involved with writing. In college, I was a math major and an English minor, actually. So I always wanted to write. When I was young, I thought I would be a journalist. I came in second place in a poetry contest in high school. And so there's always been this writing side of me. And so for me now, it's awesome that I have a career where I can be mathy but also write. And I'm also interested in photography, so I'd probably be something in journalism. I'm not sure what, but it would probably bring in the photography and writing. And
that sounds great. My guest has been Amanda Jansen from the University of Delaware. Thank you so much for being here.
Thanks, Sam.